for any given string. How about non-null? So you don't need to worry about the null case. And then given integer I, just one variable I, such that I is a valid index for getting a character from the string. Let's say I and then s the length -1. All right, it's a valid index. So we got basically s, we got I. So there is a way, just for like a property purpose, there is a way to reconstruct the string s by splitting it into two substrings. All right. Think about it this way. I'll put it down first, and then I'll visualize that for you. Just a moment. So let's say we got s dot equals, and then I'm going to put some expression here, which is going to be a string. And I'm going to concatenate two substrings over here. The first substring is going to be computed using s dot substring. Okay, I'm going to put something here. Also s dot substring. Here. All right. And then, okay. Oh, I might want to leave more space over here. Okay, first of all, the beginning index should be 0. The ending index should be s dot length here, because it's exclusive. So I cannot say -1, right? If you put the s dot length over here, it's going to make sure it's only going to go up to s dot length -1. Right? Okay. Okay. And now I can simply put I here and I here. It's a property that's always going to be true, meaning that equals is going to be true. Very easy to prove this visually, what you justify. Think about this is a string, character array. We start from 0. We go all the way to s dot length -1. So that's why you can see s dot length +1. Sorry, it's this index here +1, so that's excluded, right? So we still go up to including this index here. And then I'm saying the following. If I choose an I in the middle here, this part over here is going to go all the way, but excluding I. And this part over here is going to go all the way from I until the end. That's a visual justification, which we're going to do a lot in 2101 next term, if you take the course with me again. All right, we'll see. All right, so that's something you can think about. Okay, that's a nice mathematical property to always kind of reinforce your understanding. Good. Okay, I would suggest we take a short break by taking attendance. After the break, I'm going to spend about maybe 10 minutes or so going over 1 or 2 recursion problem on the string, and then I'll talk about the exam. Okay. Let me pause the. All right, so we're gonna go over 3 problems in total. We may just go over the first one, I guess, or maybe second one a little bit. But we're definitely gonna finish that on Thursday, and then on Thursday we also need to learn about how to do recursion on arrays. All right, that's something we need to learn too. All right, the first one here. Do you guys know what a palindrome is? Okay, by definition, a palindrome is a word, a string that will read the same forwards and backwards. All right, so for example, one moment, sorry. Is empty string a palindrome? It is, right? Empty string, read the same forward and backward. Also, if I have a string of a single character there, that's also a palindrome because A reads the same forward and backwards. And what about madam? Palindrome, right? Okay, you can verify yourself. Madam, if you read it forward, left to right, and right to left, just madam. How about race car? Okay, that's also a typical one. Okay, how about man? Apparently not, right? So it will be man forward, NAM backwards. Okay, I got enough idea. One thing I want to point out right away. When you are trying to design a recursive solution to some problem you may not have seen before you can sketch any idea, this will be the very first step. You want to go over simple and reasonably complicated example at the same time to see what the output should be. Right? You can only get some inspiration if you have enough insights or understanding about the example. So always go over some example, which I'm trying to do right now. Okay? And then in those examples, there will be the so-called base cases. You can see typically if you're doing a string, empty string is a very popular like a base case, or maybe a string with a certain very small length, like a length 1. So these two are the base cases. Other cases will be considered as way too big for me to solve right away. Those are the cases I need to think about how I can somehow divide the original problem into sub-problem that's actually strictly smaller. All right, let's now focus on this one here. Okay, palindrome, that's the first problem. Let me give you some insights about the problem, the solution itself. And then to see if you can kind of see the procedure of deriving the recursive solution. If I think about a race car over here, it is a palindrome. If I try to read it forwards, the first character I will see would be R. And if I try to read it backwards over here, I'm going to see the first character R as well. So this one kind of tells me, if I kind of imagine that, I'm trying to read forward and backward at the same time. I'm basically comparing R and R, A and A, C and C, and etc. Right? That's basically what forward and backward really works conceptually. That's insight number 1. Insight number 2. Let's say I am trying to, let's say this one here. Let's say take this string, for example. If I still try to do conceptually reading forwards and backwards, the very first character I'm going to encounter will be A here when I read forwards, and S over here when I read backwards. As soon as I see that this character here and this character here, they are not the same, do I really need to read forward anymore? I don't need to, because there's no chance they are palindrome. Right? This tells me insight number 2. When I try to read forward and read backwards over here, as soon as I see the very first pairs of character, they are different. I should stop right away and tell you that it's not palindrome. On the other hand, when I see the R and R over here, they are the same. That doesn't really mean it's going to be a palindrome ultimately. At least I have a chance to reach a palindrome. All right. So these are kind of the insight I can see right away from the examples. All right. So given this, I'm going to give you guys some visual hints. All right. So think about here, right? And then over here. Let's take a look at this one here. So the way to really design a recursive solution is, I know that I should somehow get a strictly smaller problem in order to recur on. What can be a strictly smaller problem? I know that if I already have read R and R over here, and I know that these are equal, so I do have a chance that this strictly smaller substring here may be a palindrome, or maybe not. I'm just going to run through the same procedure to, again, compare A here and try to look at whether the middle part is also palindrome, and so on. So the way I'm extracting the strictly smaller problem is by getting rid of the first and last character here, and then see what's the middle. All right, that's kind of the insight into coming up with a recursive solution. So here, this one sounds pretty straightforward, but I do want you to remember, when you want to come up with a recursive case, always think about what kind of strictly smaller problem am I going to derive from the original problem. That's the key. All right, strictly smaller problem. So imagine that I'm trying to program a Java method called palindrome, is palindrome. And I'm given the string race car. That's what I'm given. All right. So what I will do is I'm going to somehow compare the first character and the last character over here. And then I'm also going to assume I got a solution to whether or not this particular strictly smaller or strictly shorter substring is a palindrome or not. So what I really meant by was this one can boil down into R equals R, and I have some solution to the strictly smaller problem, which will be is palindrome, and then I got ACECA. Right? You can see this one here compared with the original string is a strictly shorter, strictly smaller problem. And of course, this one here might require further recursion, but understanding the first step here is important. Right? One more thing before I show you the Java code. Just remember, the critical thing is to look at the original string here. That's too big for me to get a solution right away. You want to think about how can you get down to some strictly smaller problem. For palindrome, I just get rid of the first two characters here, and then this will be everything that's left from the two characters removed. So that's a strictly smaller subproblem here. Okay. All right, that's now, okay, I think that'll be it. I can go over the solution with you quickly and do one tracing, and then that'll be it. I can continue from Thursday. Just finish this example here. So this is Java method, is palindrome, returns a Boolean, and takes a string. And the base cases will be when the string length will be 0 or 1. You just return true. All right, that's the base cases. And the recursive case will be we get the first character and last character. So at index 0 and at this particular index, the last index, right? First and second, and the middle will be here. So think about what we're doing here is, if you got your original string over here, think about this is the first character. And this one here is the last character. And this one here is the middle part over here. Right? You want to convince yourself that this substring expression here is really corresponding to this one here. Right? That's something we covered already before the break. Okay, I'll leave that to you. And then we're going to return a single expression here. So it's going to be the first character equal second character. And remember short circuit evaluation, meaning that if this is already false, I don't bother to go any further to the right-hand side. I will only go to the right-hand side if this is already true. All right, just remember short circuit evaluation. Okay, let's do some very quick tracing just to show to you. And then I'll talk about the exam. Okay, let's do maybe a shorter string. So we don't need to do a very long string to try. But I'll give you some exercise to try. So why don't we try is palindrome. Okay, let me just, okay, how about this? Is palindrome, why don't we say A, B, C, B, A. Okay, it's a palindrome. This one boils down into, okay, we got to do ampersand calculation, right, over here. So it's going to be first character, A and A equals A, and then is palindrome, the middle part will be B, C, B, right? Okay, let me use a different one here, B, C, B. All right. And this part here, we can definitely calculate. That one there we know is true. So, because of short circuit evaluation, we can now proceed to the recursive call. So this one here, we're going to look at B and B. So boils down into B equals B, and also is palindrome C. All right, you can see the C here is in the middle, right? And this one here is indeed one of the base cases, right? When the length is equal to 1. This one here is going to give us true. And we know that this one here is also going to give us true. So true and true. So I forgot to put ampersand here. All right. So true and true, that means is palindrome BCB should be true. And then what about is palindrome the bigger problem? It's going to be this part here and this part here, which we know already true. Overall, it's going to be true. The high level tracing here is much easier to manage. You just got to practice a little bit more. All right. Okay, exercise for you. Okay, I'm going to write it down. Try the following. Number one, why don't you try the race car example? Okay, it's palindrome, race car. Okay, another example you should really try to trace is palindrome. How about this? All right, give a try to both. All right, exercise number one, exercise number two. All right, the second problem we're going to talk about will be something called reversal, which I'm pretty sure you have seen in the first year using a loop. But today we're going to look at the last two problems on string using recursion. All right, if you look at the slide, it'll be slide number 16. All right, so what's a reversal? What's a reverse of string? Basically, just write it backwards. For example, if you got empty string, the reverse should be just itself, empty string. If you got a single character string, it will just be also itself, reads the same. We're thinking this way. So when you actually look at the string, read it backwards, it will be its reverse. Similar to palindrome, a little bit. All right, AB should be BA. ABC, CBA. ABCD, DCBA. Right? That's a reverse. Given a string, return another string as its reverse. And we want to solve this problem here recursively. All right? And the critical thing is, number one, you should really choose maybe some concrete example to analyze, to build some intuition. Number two, based on that example, make some decision about how you're going to divide the original too big problem into something that's strictly smaller. That's going to be the steps. All right, let's do that. All right, let's now take a look at the reversal. And please don't be distracted by this just yet. Okay, only here. If we look at ABCD, we want to calculate its reversal. Of course, ultimately, we're going to get DCBA, but that's not the point here. You want to think about, in order to really make a reversal of this, right, I need to somehow divide it into two different parts, basically. Maybe one part is something I can handle right away. The other part is something I'm going to call recursion on, right? So now in this case, I can tell you the insights right away. I'll give you some visual hints. All right, that will be the visual hints I'll give to you to start with. That's not the only way to solve it. There are actually more than one ways to solve the reversal problem. So here I'm dividing the string into two parts. The first part contains just the head of the string, the first character. The blue part is basically the substring containing everything except for the head. And the thinking goes like this. This part here is pretty small, so I can just take it by itself somehow to be combined later. And this part here, let me just make it orange just to be consistent with the color. There we go. How about this? Sorry for the distraction here. All right. So that's the 8. That's the first character. All right. And then the second part here is the remaining part of the string. That will be the strictly smallest subproblem, which you might make a note quickly. This will be the strictly smaller subproblem. And remember, phase number 3 in solving problem recursively in general, you should assume you have a solution to the strictly smaller problem. In which case, I will assume, let's say I'm using a method called reverse off. Let's say I have a method here called reverse off. Reverse off. Let's assume I already got a solution to the strictly smaller problem, which is BCD. That is, in order to calculate the reverse off of the original problem, this original problem here is way too big. So I divide that into this part here and also this part here. And for the second part here, I just assume I have a solution for it. So now I got two pieces. I got this piece over here. I got this piece over here. Now I just need to somehow massage them together to make the solution for the original problem, right? That's kind of phase number 4. Any idea how to combine these two together to make a solution for this original problem? Do I, for example, it's a string, right? Can I just concatenate these two together? That one will be on the right track, but not exactly. I tell you why. If you look at the reverse of BCD, conceptually it would be DCB. So if I simply try to concatenate this directly to this, I got A DCB. It's not exactly right, is it? So it will be correct if I try to say, rather than putting that here, what used to be the first should now be the last in the reverse. All right, that's the inside. So what I will do is, I'm just going to put this guy here to the end, right? So what's going to happen is, put the reverse of here, and put the first character that used to be now to the last. So this will be what's going to happen here. Recap. In order to solve this reverse of this particular problem recursively, I'm going to divide the string into the first character and the remaining string. For the remaining string, which is strictly smaller problem, I assume there is a solution by making a recursive call, BCD. I know that conceptually it's going to be DCB, ultimately. And then for this first character here, what used to be the first should now count to the last for the reversal. So kind of concatenate them together. All right, so that's the sketch of the solution for the single example. So that's a single example for recursive case. And for the base cases such as empty string and also single character, I already know they should just be trivial to calculate, right? I just need to code them up in the Java. Any question about the recursive case here? All right, before I show you the Java code, I'll give you something to think about. All right, I'll put as exercise here. The hints I gave to you over here was the reverse of the string. Let me just copy that. I'm going to give you slightly different visual hints. What about I want this one here to be looked at first? And then I want this guy here to be the strictly smaller problem. How would you define the recursive method accordingly? That will be exercise for you. Think about it. All right. All right, let's now stick to this initial intuition, and let's now take a look at the Java code, which would be very similar to what we had for the original one, right? Okay. I kind of went to the wrong page, but anyway, I'll fix that when I release the iPad note. That's okay. All right, so now let's take a look at the code for reversal of the string over here. All right, so this will be the base case. When the string is empty, reversal will just be empty string. When the length is simply equal to 1, just the same string, right? The reversal. And in the recursive case, now I can visualize that a little bit for you. S is a string pointing to an array of characters over here. And then we got something called a tail. The tail is going to be everything starting from index 1, from the second element until the end. So you can think about this part over here is the tail. This part here, all right? This part over here is the tail. And then this part over here, we also got head, which is the first element. This part over here is the head. And the idea will be we want to construct a new string somehow. And the way to do it is we're going to get a reverse of the tail and then put it here. And then concatenate head to the end. Okay, I'll draw that. Now the reverse of that is going to be just another string, also S prime, okay, just a different string. And that one there is going to be something equally long, okay? And then you can think about this part over here is going to be not exactly tail, but the reverse of tail. So this will be the reverse of the tail. All right, think about what used to be the tail over here is now going to be reversed. And then what used to be the head will now become the last element in the reversal. All right, that makes sense, hopefully. And then you can simply look at, in the Java code here, we are making a single recursive call on the tail. And we're going to get the result over here and concatenate the reverse of tail with the head, right? That's exactly what's shown on the diagram. So you can see we got 100% correspondence to how we did the conceptual sketch. So I will really advise you, whenever you got any problem about a recursion, before you even start coding in any language, try to do some conceptual sketch on some concrete example, like what I did. For example, like over here, right? Again, I'll fix that when I release the node over here. Okay, like here. That's how you did it. All right, any question about the reversal over here? If no, let's do some high-level tracing quickly, and then we can move on to the next one. So let's say I want to do something simple. If I want to do the reverse, I'll say R, just for short, okay? The reverse of, let's say, A, B, C. All right, I'm going to divide that into two parts. First part will be A, second part will be B, C, right? So this one is going to boil down into two parts, concatenated. So it's going to be the reversal of BC plus A. And then this part over here is going to be, again, divided into A, B here, the first one, and the remaining part, which happens to be a single character string, which is the base case, which is good. That one there is going to be boiled down into, and let me just move a little bit here. There we go. So that one there is going to be, now the B here is going to appear to the end. Concatenated with, now this will be the reverse of C. And we know the reverse of C is going to reach this particular base case, which is going to be the string itself. So this part here is just going to be C. All right, so if you look at the final answer, CBA. All right, that's how to show informally that the recursive method actually works. All right, any question here? That's good. All right, you can definitely try maybe different example there, maybe a longer string, just to be sure you really know how to trace this kind of way, the high level. With the call stack, you can just stick to the Fibonacci example. That will be enough. All right, if no further question, let's now do another one, the final one on the string. All right, now we're done with this, which is on slide number 16 for the conceptual sketch and slide 17 for the Java code. All right, the final one. And this one here, again, you can easily write a loop as well, but we want to force ourselves to think recursively for this one here. So we want to write a recursive method that's going to take input string and another input, which will be a character C. And we want to calculate how many times the character appears in the string. All right? For example, let's say here. Let's say we're given empty string here. How many times does A appear empty string? 0. All right? Nothing. Basically, given empty string, any character simply appears 0 times, always. And what about here? 1 time, right? If you got a single character string A, how many times does A appear in that string? Just 1 time. All right? On the other hand, if the two strings don't really match, I got a 1 character string which contains B, but B does not really match the string I'm matching A. So 0 times. All right? All right, final one. How many times do I have A here? 1, 2, 3. 3 times, right? I'm sure you can see that. All right? And another extreme case would be, let's say we got a long string here. How many times does C appear in that? 0 times. There's no C. All right? Now you guys got the idea. First of all, we have to figure out exactly what should be the input, what should be the output before we look at a solution. And let's now try to have some conceptual sketch. All right? And now we can take a look at here. Okay? Number of occurrences. Then let's take this example let's take this one for example. Okay, so let's say we have some method called OCC, occurrences, just for short. And then let's say we got 2 different calls. One would be we want to find about A. You know what? Let me delete these 2. And let me copy this. I'll do another one to show to you. Let me put that one here. Okay, we'll talk about these two different methods of call. And this one here will be, let's say, B. And we'll try to build our conceptual sketch from these two examples here. All right, so we got A, B, C, A, the same string, but we want to find how many times A appear here and how many times B appears in this string. All right, the exact answer you know pretty well. All right, the way I see this one goes like this. I definitely cannot try to process the whole string. That's too big. I need to divide that into something small and a strictly smaller problem, at least, in order for me to call recursion. And typically, if you got an array of characters, like a string, you can always assume, you may just want to find the first one to see if that might work. Okay, sometimes you may have to look at the first and last one, and sometimes you may have to look at the middle one, only a single character, different way. But let's say I try the leftmost one. If I look at this part here, so that means I'm going to divide that into A and the rest. Here, similarly, A and the rest. This is how you can think of it. I will compare first character here with the one I'm looking for. If they are equal to each other, I know that for now, until now, I got occurrences of 1. As far as this part of the string is concerned. For the rest, I don't know yet, but I can assume I have a solution for that because it's a strictly smaller problem. All right. What about this one here? Again, I compare first character and B here. They do not really match. So as far as this part of the string is concerned, I got 0. But I still need to calculate how many times I have over here, which I have a solution I can assume. And then whatever answer I got here, I'm going to say plus 0. Whatever I got from here, I'm going to say plus 1 because these two match. All right? So what I really meant is, let me write it down. Compare A and A, they match. So this one can boil down into 1 plus the occurrences of B, C, A. And this one is going to be A and B, they don't really match. So it'll be 0 occurrences for that part of the string, plus the occurrences of B, C, A. You can see in both cases, we got the same strictly smaller problem over here, but we got 1 versus 0 because it depends on whether the first character here will match the input character here. It depends. Right? We got two different cases, meaning that when you want to code this up in Java, you will need some conditional, if then else, which you know how to do. All right, any question about the conceptual sketch over here? All right. Your classmates from the morning session also asked me a very good question. Dividing this way is a very good way, for sure. Okay, I'll give you some exercise to try. What about I got occurrences over here, and then I still got A, B, C, A. Let's say I want to divide the string in the way I do for palindrome. All right. I want to look at the first and last character over here. And then the strictly smaller problem will be the middle part as opposed to tail. And then now I need to compare somehow A here. But how do I exactly work out an equation like this? All right, that's the exercise. All right, think about it. If you need help, let me know. All right, so this is another legitimate way of doing divide and conquer. Not very typical, but it's doable. All right, think about it. Okay, after this, let's look at the Java code. So for number of occurrences, so we got occurrences of, and we got string, we got character here. And then base case, if it is empty, just return 0. All right, and then we got a head. Okay, let's see this. So let's say the string S is basically this one here. And then we divide that into two parts, basically. So this part here is the head. As you can see, we try to extract the head. And also, we got the tail by using the substring method. And that's something I assume you guys know how to do it, right? The tail. And then double check yourself how to specify the substring range over here. So this part here is the tail. So we basically say we're going to compare the character C over here with the head. We're going to say either the head is equal to C or the head is not equal to C. There are only two cases. If they are equal, we're going to say 1 plus. The otherwise, we say 0 plus, right? 1 plus. Otherwise, say 0 plus. And this part over here is going to be the recursive call on the tail, which is what you see exactly over here. Right? It's going to make a recursive call either here or here. And then on the tail, and then with the same character. Right? So that's exactly what I have over here. Right? All right, any question about this method here? Okay, so really thinking recursively is not too bad. You just got to think about how you can divide the original big problem into something just strictly smaller. Okay? And then think about how you can combine the solutions of the strictly smaller problem and make it the solution of the original problem. That's what you got to do. Okay, let's now do one quick tracing. Quick one. So let's say this. Let's say occurrences of, let me say A, B. And then I want to see how many times B will appear in this string. How about that? Make it very simple. And don't forget, we only got one base case, just 0. Okay? So this one is going to boil down into, now, number one, we compare B with the first character B. And this B, we'll compare B with the first character A. And the remaining part will be a single character string, B. And it's going to boil down into, in this case, we know that A not equal to B. A not equal to B. So now we know that it should be 0. Now think about this is the number, this is reasoning, right? Because they are not the same. So it should be 0 occurrences. And then plus the occurrences of a string of a single character. And then we check B. Okay? And then for this one over here, we are not reaching the base case just yet, so we're going to go further. And this one here, how do we divide that, right? Think about the B here is a single string. So we take the first character, that will be the head. What about the tail? Just empty. Right? It's as if you're trying to concatenate B with empty string. That's how you get this string. That's the tricky bit, right? So here, the tail will just be empty. Okay, that's a tricky bit you got to notice, all right? So this will boil down into, since I know B equals B, so I know that that part there is going to be 1. And then plus the occurrences of empty string. All right? And then I know that this part over here has reached the base case over here because that one's empty. So this one will be 0. And now if I want to add them up, I got 0 here, 1 here, and 0 here. So 1. Right? That's the correct answer. So the ultimate answer for this one here is going to be 1. But the way you trace it is by looking at how the recursion is going to break down, divide and conquer. All right? So this ultimate answer is going to be just 1. Any question here? All right, I'll take silence as no problem, right? Yeah, just make sure you know how to do this because in the exam, I might also give you a slightly different problem there and ask you to trace like this, right? You should also know how to really boil down the original problem here into something sub-problems based on the definition here, right? That's something you should really follow through. Okay, if no further questions, let's now move on. Okay. All right, so that's about the recursion on the string. And now I'm going to switch the context a little bit. The input now is not going to be an array of character, just an array, primitive array. And the slides that we're going to talk about will be here. Let me show to you. Okay, slide number 20 over here. Okay. And our idea would be we want to run recursion on an array. And this is the kind of problem you will see in the past lab that are made available on the lecture site, right? So all the problems there are more or less on that particular category. So the idea would be, if you actually want to run recursion on an array, how can you make a strictly smaller problem? In the case of the string, we can use a substring method. Now, in the case of the array, we don't really have that method there. So let's try the naive solution. The naive solution would be, let's say I got an array of size 10. How can I create a strictly smaller problem of size 9? I can create another array of size 9 and run a loop to copy over every element there, make a subarray. But that one there has two very bad inefficiency. Number one, I need to create a new array. That's a waste of space. Number two, I need to run a loop to copy over all the elements. So when you guys go to 2101, this is a very bad detrimental factor to the efficiency of your method. But that's something we'll cover next semester. Not yet. So what I will do is I'm going to go over with you about the two different solutions, and then I'll first of all go over the naive solution. That's also worth noting to understand how exactly things are going to happen. And then I'll show you the ultimate pattern that we're going to all follow, okay, for the exam. And this is a common pattern, right? I didn't really just make it up by myself. It's not unique. It's very standard. All right, let's talk about the naive one first, which is inefficient, space-wise and speed-wise. Very inefficient. So let's say we are running a method here, and the input is simply just an array. Can be integer, can be string, can be anything. Let's say it's an integer array. And then we say the two base cases are, if the length is simply 0, empty array, we do something. If the length is 1, another base case, we do something. So typically, if you try to run recursion on an array, there are two base cases, either when the array is empty or when it has a single element. Okay, so typically. Okay. And then this will be the recursive case over here. So the recursive case goes like this. I'm going to create a strictly smaller problem called sub. That one there is going to be a very strictly smaller array. And then I'm going to run a recursion on that. Okay, let's visualize that quickly. The input A goes like this. So let's say it goes from maybe 0 all the way to, let's say, 99. Let's say, okay? 100 elements there. In order for me to run the recursion, let's say I want to somehow disregard the first element because that has been processed already. I want to look at the rest of the array as a subarray. So I'm going to do by creating another array called sub. So the sub over here is going to contain everything starting from index 1 of the original array A. All the way to, so you can think about index 0 all the way to index 98. So what used to be at index 1 in the original array is now at index 0. What used to be index 2 is now at index 1, and etc. Okay, I'm copying over. Just disregard the first element. Okay, one little exercise for you. Take a look at this loop over here. That one there is basically doing the copy from element number 2 all the way to here to copy that over here. That's exactly what it's doing. I'll leave that exercise to you. All right, that's not difficult. It's more like a first year level loop to execute. Okay, so once we got this subarray over here, you can see it's a brand new array, which is going to occupy almost double the space that we need in the memory. Pretty bad. And also to execute this loop for that many times, that's also very bad. We're wasting time and wasting space. And when we call the recursion, call the M method here on sub. So this one here is the main thing. We are calling making a recursive call on a new, strictly smaller array. Okay, that array there, strictly smaller to make it a recursion valid, but it's also new, meaning that we're wasting space. All right. Let's now visualize a little bit about tracing, okay? And then we'll talk about the efficient way of doing things. In base cases, let's say this. If I have, let's say, calling M on A1, A1 is simply just empty array. That one's easy because as soon as you hit this branch over here, A.length equal to 0, true, so base case. So that one there is going to be base case number 1. No array need to be created in the base case. What about this one here? This one here is not base case. The size is larger than 1. So what I will do is, let's trace in this way. I'm trying to call n on the array, which is ABC. And I'm going to visualize that right away here. A, B, and C. 0, 1, and 2. That's the array as the input. The first recursive call is actually going to prompt me to actually create a sub, right? And then call that. So that means I'm going to have a recursive call, and that one there is going to be a brand new array. I'm going to use a different color to tell you it's a brand new one. And that one there is going to be of size strictly smaller. So index 0, index 1, and I got B, C here. So A presumably has been handled already before the recursive call. All right. And then let's now move on a bit. And then I have the second recursive call. And then that one there, I'm going to presumably already process this one here, create a subarray of size 1. That one there is going to have just one elements array. That's brand new. Index 0 and C. Now we have reached the base case, because you can see this one here, when I call that on n, we're going to reach this case over here. Right? The length of the array is equal to 1. So this is base case number 2. Base case number 2. However, the thing to note would be, you can see these subarrays have been created time and space wasted to create these subarrays. So in practice, that's something you shouldn't do. But conceptually, you should understand that's what we are trying to achieve. And there's a more efficient way to do it without a loop and without creating new array. That's what we're going to show. Guys, any question? Yes, please. Mm-hmm. Yep. 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 Mm-hmm. Yep. Yep. Absolutely. That's pretty clever. Your classmate suggested exactly what I'm going to talk about in the next slide. All right, that's good. So there are 2 things he mentioned here. Okay, number 1, we don't want to create a new array. How can we achieve it? Call by value. All right, does that sound familiar? All right, call by value meaning that we only pass the address of the array for the original input. We don't need to create one. Call by value, we pass the array reference. Number 2, rather than giving you the array of the strictly smaller length, why don't we try the following? Conceptually, I'm going to make it more precise. Let's say I have a reference to this particular array. And then initially I say I want to look at this particular range from 0 to 2. When I make the first recursive call, I still want the reference to the same array. But now I'm going to tell you, looking at the same array, I want to look at from the range of 1 to 2. So the only difference is I go from 0 to 1 to 2. I'm only trying to play with the integers I'm passing to the method. That's kind of the insight. All right, that's something I'll make it more concrete to you in the next page. So that's a pattern that you guys will have to learn, which is not too bad. We're going to learn, we're going to go over the pattern itself, and then we're going to take a very short break, and then we'll look at 2 examples, okay, to make sure you're comfortable with it. All right, let's look at exactly what your classmate suggested here. All right, so now the same method here, n. And then we got an integer array, the same as before, but now we got 2 extra parameters over here. That's the critical key, right? So here we got from and to. You can think about the from and to over here will form some range of elements to look at in the method call, okay? So these will form a range of elements to look at in the current method call. Because the same method might be called multiple times, since we have multiple recursive call. Each call is going to look at a different range, okay? In the current method call. All right, so here, this base case over here, okay, how about this? Think about, we got an array over here. And then we're going to specify the indices as from and to. When the from is exactly equal to 2, that means we want to look at a particular element in the array. Maybe, let's say, 3. Okay? The way to say I want to look at element 3 is the from will be 3 and the 2 will be 3. That's one base case. And then, what about from larger than 2? This is a special case where it really means we are reaching the base case where there's no more element to look at. Okay? Typically, from should be less than or equal to 2. Okay, I'll see here. For non-empty range, from should be less than or equal to 2. All right, so this is some important insight. Okay. However, when this less than or equal to is not the case, that means larger than. That tells you that we are specifying an empty range, pretty much like how you specify the substring method. Okay, there's a mathematical property inside, but let's not dive too much into it. Okay, I just want to tell you. Another way you guys can try, I'll put a formula here, you can verify yourself. If I got from and to over here, how many elements exactly are there in this range for me to look at? Okay, it'll be 2 minus from plus 1. For example, if I got from 2 to 4, it will be 4 minus 2 plus 1, which will be 3. All right, that's a formula for you to think about. And if you apply this formula over here into this case, it will give you exactly 0. If you apply to this case, it will give you exactly 1. All right, anyway, that's formula just aside for your information. And then in the recursive call, we're just going to pass the value here. This is call by value. All right, that's something you don't want to forget. Call by value. Don't create any subarray. No loop, no new array. And then the only thing we change is we're going to shorten the range of indices we're going to look at. In this case, just say from plus 1. And then 2. Okay? How does that work? Let's say this. If I got my array like this, in the beginning, I want to go from here and to over here. It essentially covers the entire array as the range. When I try to make this particular recursive call, I'm basically still referring to this array called by value. But now, when I look at the from plus 1, that tells me I should start from the second element here and go all the way to here. Now, you can see the blue and the pink. So the range of element that's being covered by the blue is exactly one element larger than the pink over here. Or you can say the pink is a strictly smaller range of element to be looked at in the array. So that's how we create a strictly smaller problem in the recursive call. Some tracing quickly, and then I'll take your question. So this one here, we got A1, empty array. And when we try to pass into the method here, so A1, the reference, and then beginning index will be 0. The largest index will be A1.length minus 1. Right? That's always the case. And then you can see this one here will happen to be A1.length will be 0 because it's empty minus 1, which will be minus 1. So now 0 and minus 1 is going to match this branch here because 0 is strictly larger than minus 1. So that's base case number 1. All right, that's important for you to see. Base case number 1. All right, I'll pause a little bit. Any question about base case number 1 here for empty array? We're good? All right. What about non-base case? Let's say, again, we got ABC. Before, we talked about how you have to create subarray wasting spaces. Now we don't need to do that anymore. All right, let's see exactly how it's going to go. So we got our array A2 pointing to an array with 3 elements, A, B, and C, with indices 0, 1, and 2. And then the method call that we want to start from will be this one here, all right? Which will be the method n, A2, just the reference, call by value. And 0, the beginning index, the ending index will be A2.length, which is 3, minus 1, 2. So this range over here specifies the entirety of the array. Agree? Okay. And then the first recursive call, we're going to boil down into another call to n, still the same reference A2, call by value. And then this time here, from plus 1, 0 plus 1, 1. And 2 remain the same, right? You can see the 2 here doesn't really change. But later on, once you get more confident and more creative about this pattern here, maybe there will be some problem that requires maybe 2 to be decremented, maybe. But for now, let's stick to the 2 doesn't really change. So when you look at the 1, 2 over here, it's really specifying this strictly smaller sub-range, right? We're ignoring the first elements already. And let's say this one here, another second recursive call. Again, A2, call by value. And now 1 plus 1 will be 2, 2, 2. Right? So just don't forget, from plus 1. So 2, 2 over here is specifying exactly this range over here. And now we have reached the base case. Because this one here, where from is equal to 2, has reached the second base case. From is equal to 2. And we do something. All right? So this one here will be the second base case. Base case number 2. Number 2. All right, any question about this pattern here? This is only like a conceptual sketch about how the pattern should work. But the critical bit is every time you're trying to determine the base cases or try to make a recursive call, you have to play with the 2 indices. You don't really play with the array. No, you don't. The array always stays the same. Okay. All right, if no further question, I would suggest we take a very, very short break, take attendance, and then when we come back, I got 2 problems to walk over with you. All right? Okay. All right, so let's now go over 2 examples on the recursion on the array. So if you look at the slide, what we just went over before the break was slide number 20. And then let's now take a look at the first problem here. I think these 2 problems are pretty much similar. So once we understand the first one in more detail, the second one should be more straightforward. How about that? I wouldn't say 100% straightforward, but more straightforward. Okay, given an array of integers, I want to return true if all the numbers in the array are positive. Otherwise, if I can find a negative number there, it should be false. I'm pretty sure you know how to solve this by using a loop very easily. But again, let's now think recursively here. So given an array, I can tell you the inside right away. Given an array that might be too large for me to solve right away, why don't I look at the first elements? If the first element is already negative, there's no way the whole array are all positive. I can return false right away. But if the first element in the array is actually positive, then I have a chance to have all elements in the array being all positive. So I still need to run a recursion on the remaining part of the array, which will be from plus 1 to 2. Right? That's something we talked about before the break. And for this problem here, we need to, let's now do a little bit quick check. All right, so for this one here, if the array has only, okay, I'll talk about this one interesting. I'll talk about it last. If the array is this, true or false? True, right? All positive. This one here should be true, all positive. This one here should be false because I can find something negative. All right, easy to judge. And then let's now talk about base cases here. If there is only one element in the array, I can just check it directly. If that one is larger than 0, it should be true. Otherwise, false. What about empty array? Should I return true or false? I cannot return both. True or false? Anyone? It doesn't seem like I can find any positive number here in the empty array. So maybe I should return false, no? I heard no. Okay. Who said no? Why not? True. I cannot find negative either. I cannot find positive. True. Then should I return true or false? Who said true? Ah, why? Because it's not false. It gotta be true, right? Sure. I agree. Yeah, I like that. Sure. Okay, go ahead. Ah, I like that. Because there's no number there which we can find to disprove the property. So it must be true. I like that. All right, good. But I want to write down something just for your information. It turns out to really make a decision about this, some logic is needed. A little bit, not too much, okay? Have you guys ever seen this thing in your life before? Yeah, okay. What is that? For all, good, good. And this one here? They exist. Okay, good, 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 good. Sorry. Good. So when you ask about things like if all the members in a collection are satisfying some property, it's a universal quantification problem, really, mathematically. Okay. So I'll write down very quickly for your information. If I say for every x, and some property of x should hold for every member in the range of x possible. And the property over here can be whether x is positive, whether x is negative, or x is even number, and etc. Okay? Now, the special case we have is x over here is a member of empty. Right? So now this axiom or theorem, you can look go back to the 1090, and that one there tells you it's always true. Always true. On the other hand, when you got the existential quantification over here, some property over here, if I know that the special case is a member of the empty collection, it's always false. Nice theorems to be aware of, and we are really applying that into our programming context. All right, very quick justification, and then we can move on. This one over here is true because there is no witness to prove otherwise. To show some violation. Because no violation can be found, so the property must be true for all members. All right. On the other hand, for the existential one, it's a little bit more straightforward. It's actually false because there's no witness to show that there's a satisfaction of the property. So it's false. There is no witness to show some satisfaction. All right, so here you can easily modify this problem here. I'll let you do that. Rather than are all the numbers positive, what about I say is there some numbers positive, right? In that case, we're basically moving to the existential problem. In that case, if the array is empty, I should return false, all right, and etc. All right, you don't really have to know exactly how this works. I'll refer you to maybe your math course, but it's very useful to know this one as a background and then know how to derive the default values. All right, let's talk about some recursive case, and then we can look at the Java code, and then we'll do one tracing with you. And for this one here, the way to think about it is I'm going to break down the array into two parts. First part here, and first part here. All right, let's look at the indices. Indices, I got 0, 1, 2, and 3, 4 elements. So I can think about the way I'm going to run the recursive call will be, let's say I got some method all positive. Okay, just for short, all P, positive. And then I'm going to pass the reference of A. In the beginning, I want to look at the entire array. So that will be from 0 to 3. And you can think about the 3 here is A dot length minus 1. All right. And to really do this one here, I need to break down into, okay, 4 here is the first elements, which will be A at index 0. I can first check to see whether that one's positive. And then, do you remember short circuit evaluation? Right? I want to say, if this is not positive, then I shouldn't bother to go any further. Right? That's exactly what the n% operator is going to do for me. All right. So this one tells me if A0 is not positive, which means less than or equal to 0, bypass the right-hand side. That's short circuit evaluation from before. Okay, that one should not be new to you. And then, what if this is already true? That means we have a chance we should really look at the rest. And to look at the rest, I should really say all positive, right? You can see the same method call, all positive over here. And then I'm going to have the same call by value, the same A here. And now any suggestion about the numbers here I should pass? Cannot be 0, 3. In that way, I'm not decreasing the size of the problem. I heard 1. Okay, I'm pretty sure somebody said that. Okay, so it would be 1 and 3. So think about 0, 3 over here is basically specifying the entire range over here. On the other hand, 1, 3 here is specifying everything except for the first element, subrange, which is what we spoke about before the break. But now we just applying that in a concrete problem. All right, any question about this? And for this one here, I'm going to do some tracing with you, okay, in a moment. So that's the conceptual sketch. That's basically a recursive call you will see in the actual method. But let's now take a look. So the Java method here will go like this. And one more concept I'd like to bring to you is a very practical one. So you can see this method here, which will take the array and also the 2 indices. You can see that one there is calling itself. So this method here is recursive. Okay, but in practice, you wouldn't expect a user of your method to always pass integer over here to begin with. It's too troublesome. They may not know too much about the array. They just want to say, I want to give you the array, and that's it. Right? So typically, you will make this so-called recursive helper method. It's called recursive helper method. And normally, we'll make it private, meaning that it should belong to only within your class without anybody calling it except your own class. Anybody who wants to somehow make use of this recursive algorithm over here, they should call the public version here. Okay, so this method here will be the public version that should be called. So this will be the public version. So this method here is called all positive. If you look at this method here, this one is not recursive. It's not calling itself. It's basically calling the recursive helper method. Okay, quick recap. The recursive helper method here is something that you should really keep it private, only to be called within your class. But for any other outside user to use it, you should really provide a public version, which in turn, internally, is going to call the recursive helper method. All right, and to start the call, we're going to say the first index 0 and the ending index, that length minus 1. All right. And then we got base case over here when the range is empty, return true, right? That's exactly what we said over here about true. And when from is equal to 2, that means we got only one element in the range, right? In that way, check to see whether that particular element is larger than 0. So here, if you replace from by 2, that's fine, because they are equal to each other, okay, if you want to. The recursive case basically will be, let's now take a look. Let me just visualize that slightly. So we have our array A being passed around. So A here is over here. let's say in general, from could be some index right over here. And the 2 usually should just be the end, let's say. Okay. And then at the moment, when we start the recursive call, when we start this method here, right, we say from and to. So that will be exactly this range. And then when we make the recursive call, we're going to say, number 1, the from should be larger than 0. So that means this element over here should be larger than 0. And then we're going to make a recursive call. And that one there is going to be this one here. So from plus 1 to 2. Right? So this element here, we compare right away. And then we got a strictly smaller problem here, which will be this range over here, starting from plus 1, which is this element here, right? Okay. If you like, I can also put here to make it explicit for you, right? Think about this one here is from plus 1. Okay. And let's now do some tracing, and then you'll see exactly how it works. All right, I'm going to leave the base case to you. Right, you can see I already got the high-level tracing prepared for you, pretty much. In the empty array, you will just see that 0 minus 1, which we spoke about earlier, right? And for one element array, it's going to be 0, 0, and then you will just need to check the first element here. That's it. Let's only look this one here, exercise. All right, but let's do this one together. Okay, this one is more fun. Let's say we want to determine if all the numbers over here are positive. Okay. So what we do is we start with this method called all positive. All positive. Pass A, pass A. That one there is going to call the recursive helper method here. Recursive helper method here. And then we go from 0 until the length of the array minus 1. The length of the array 1, 2, 3, 4. Minus 1 will be 3. Okay. So that means for the very first call, we got 0, 3, which is going to cover the entirety of the array. And then, according to the recursive case over here, A from will be 0. So A 0, larger than 0. So check this one first. So A 0 over here is 5. 5 larger than 0 is true. And we're going to combine that with %. According to the short circuit, if this is already true, do we continue? Yes, we do. So we're going to make another recursive call. All right, so for this one here, we're going to say from plus 1. So from plus 1 and 2. So 0 plus 1 to 1. So if you compare this index here and this index here, right, you can see 0 versus 1. That's exactly the from plus 1 I was talking about. And then when I look at the 1, 3 here, that corresponds to the sub-range. Index 1, index 2, index 3 over here. Right? Strictly smaller, except index 0. And that one there is going to, again, not reaching the base case, but again, reaching the recursive case. And we're going to do, so this will be from, which is 1. That means we're going to look at A1. A1 is 3. One thing very important to note. When I was here, the from is 0. That's why I look at A from, I'll be looking at A0, which is 5. When I get to over here, I will be looking at A from, which is A1, which will be this element here. That's the critical bit to notice. All right. So now A1 will be 3. So this one will be 3. 3 larger than 0, also true. And when I do %, I still need to go ahead for this one here. I still need to. All right, so this one here, one final recursive call. So that one there is going to be 2, 3. All right, for 2, 3 over here, so that will be index 2, index 3. Basically, these two elements, index 2, index 3. And now the from here is 2. That means I need to look at A at index 2, which is exactly here, right? A at index 2 will be minus 2. So this one here is minus 2. Minus 2 larger than 0 is going to be false. And according to the short circuit, we should not even go to here. we should stop right away. All right, that's critical for you to know. So in practice, you don't even have this branch over here, right? I want to delete it explicitly in front of you, just to be sure, all right? Because this is actually false, so I know that I'm going to bypass the rest. Bypassed because of short circuit evaluation. Okay? Are we okay with this? So when you review the tracing of this example here, this is what you should note. Number one, look at how we go from this particular call into this, right? 0, 3, that's how we start with, which covers the entire range. Whenever we go down one level here, we increment from 0 to 1, 1 to 2, and presumably 2 to 3. But the reason that we don't even get to this is because we are using some operator that has a short circuit effects. Because at this one here, we already got false, so we don't even bother to go any further. All right, that's a very critical point when you review the tracing. And of course, when you do the exercise that I assigned to you over here, you wouldn't run into that trouble because at every level over here, it's just going to get true because all positive, which is okay. You can create another example yourself, which contains maybe some negative number at the end of the array. All right, so that's about the all positive, right? Any question? Anyone? All right, final problem, which shouldn't take us too long, okay? So this one here, if you look at the slides, it would be slide 23. All right, so we want to determine if the array is sorted in a non-descending order. All right. Now, this will be some term you will actually you will run into quite often in CS or engineering. Let me explain that very quickly. When I say non-descending, break it down into two parts. Descending first. Descending means when I go between two adjacent indices of the array. If I go from here to here, the value should be decreasing, which means that's the index I, index j. That means this will be aj, this will be ai. That means the value of aj should be strictly smaller than ai. All right, that's descending. And within non-descending, that means the negation of it. All right. So now think about how you can understand non-descending precisely. Descending here simply means if I got adjacent indices I and j, I got ai strictly larger than aj. Descending, right? I go from something larger to something smaller. That's descending. Non-descending means I'm going to apply some logical negation to it. How do we simplify this? That's equivalent to applying not to larger than, you'll be smaller than or equal to. ai smaller than or equal to aj. So this is the precise meaning of ai's, of the precise meaning of non-descending, which means the adjacent element can be either equal or smaller than to the next one. Okay, that's about non-descending. And you can definitely try, what about non-ascending? You can do some similar exercise over here, right? I'll leave that to you. Okay, let's now take a look. Okay, are the numbers sorted? Okay, so let's start with the base case right away. What about empty? True or false? True, you guys are good, right? Any property doesn't matter, right? You will just be satisfied by all the elements since it's empty. True or false? True, because you cannot find any violation. This one here? True, because 3 less than or equal to 6, 6 less than or equal to 6, and 6 less than or equal to 7. Okay, that's how you check. On the other hand, this one here, false, because this guy here, 6 is not less than or equal to 5. All right, good. Now let's now solve it. Let me get to the point right away. Let's say I got this one here. I cannot really determine whether this, okay, this is how I'm going to divide it. Let's say I got some method here called is sorted. Okay, I'm going to pass A here, call by value. And then in the beginning, I'm going to have, let's say, 0 until 0, 1, 2, 3, right? 3. That's how I start with. I want to look at the entire thing. 0, 3, here. Now, I got from here, sorry, this is a from index, which refer to just 3. But in order to determine that if that's sorted, I cannot only look at 3 only. I want to look at 3 and its next element, right? So what I should do is, I should really say, so this is the from. I should look at A0, which is over here, and also its adjacent elements, if this is true. Look at that first. And then I'm going to use the short circuit operator over here. If this is already false, I shouldn't bother go further because I already find some violation for the sorting. If it is true, I'm going to now look at the rest of the array. But now for the rest of the array, should I start from index 1 or index 2? 1. Good. Because once I have a look at this one here, I should look at not just 6, 7 here. I should look at 6, 6. All right, be careful with that. Very good. So that one there is going to be is sorted, and then A, and we got 1, and then 3. Okay, 1, 3, and then 1, 3. Okay, good. That's basically what we're going to do. All right. I got 4 minutes. Okay, let's now take a look. The Java code, very similar. The method here that's public is going to call the recursive helper method 0 until the last index, the same as before. We got from and to, and base case is the same as before. And now this one here, almost identical. You can see the recursive call is going to be from plus 1, 2. And then here will be from and from plus 1. Exactly what I said earlier. From and from plus 1. Okay, so try to look at this conceptual sketch over here with this one here. All right, so that's the Java code. Let's now do one tracing, and then we're done. Okay. All right, so this one easy. I'll leave that to you. I'll do the more complicated one with you. How about this one here? That one there is already kind of have the structure for you. Let's take a look. So it's sorted. Is sorted A, which is going to be this entire thing. Entire thing is going to be from 0 to 3. All right. And then by definition, we're actually going to the else part over here. So we're going to return from and from plus 1. So from, which is 0, and from plus 1 will be 1. Right? So basically, we are comparing these two first. 3 less than or equal to 6, which is the case. And then we're going to run a recursive call from 1 to 3, which is going to be this strictly smaller range over here. And to solve that, it's not a base case just yet. So we're going to go back to this else part again. So that part there is going to be, you can see this is from. So from and from plus 1. All right. That one will correspond to this strictly smaller range, which will be from here to here. All right. And that one there, we're going to check to see whether A1 is less than or equal to A2. All right. A1 is less than or equal to A2. And we got some violation right away. Agree? So this is the violation, which is going to disallow us to go any further. So this one over here, you can see A1, which is over here. A2 is over here. 6 less than or equal to 5 is actually false. Because it is false, and we got an n% over here, which is not going to evaluate any further because it's false. So in practice, you're not going to have to trace any further. bypassed. So the way we kind of execute the short circuit evaluation is just the same as the earlier problem about all positive.